HighBridge, a division of Recorded Books, presents The Last Stargazers, The Enduring Story of Astronomy's Vanishing Explorers by Emily Levesque, read by Janet Metzger. Introduction. Have you tried turning it off and back on again? This phrase, repeated by weary IT specialists the world over, had possibly never prompted such horror. First of all, it was 1 a.m, and I was sitting in a chilly control room on top of the highest mountain in Hawaii. I was nearly 14,000 feet above sea level, 24 years old, and desperately fighting through sleep and oxygen deprivation to salvage several hard-won hours of PhD thesis research time on a piece of broken equipment. Second, the equipment in question was the Subaru telescope, a 630-ton beast housed 1 floor above my head in a 14-story dome. A joint venture between the U.S. and Japanese astronomy communities, the telescope boasted a pristine primary mirror more than 27 feet in diameter, the largest single piece of glass in the world, and a suite of some of the most sophisticated scientific instruments and imaging tools on the planet. It cost $47,000 per night to operate, and after submitting a 12-page science proposal to the professors in my department, I had been granted one of these valuable nights, tonight, the only night allotted to me in the entire year, to point this telescope at a handful of galaxies 5 billion light-years away. No, I had not tried turning it off and back on again. The evening had been going excellently until one of the control room computers had produced an unsettling blunk sound and prompted the telescope operator, the only other person with me on the mountain, to freeze in her seat. When I asked what was up, she cautiously informed me that one of the mechanized supports holding up a mirror had just failed. But it's okay, I think the mirror is still on the telescope. You think? Yeah, if it wasn't, we would have heard a crash. Solid reasoning, if not exactly reassuring. We'd apparently gotten lucky with how the telescope was positioned when the mechanized support failed, preventing an immediate disaster. For the moment it was still holding up the secondary mirror, notably smaller than the primary but still 4 feet wide, 400 pounds, and suspended 73 feet in the air to redirect light collected and reflected by the primary mirror into the camera I was using. Unfortunately, if we moved the thing again, we'd be at risk of dumping the secondary mirror onto the floor, and that was if we were lucky. If we were unlucky, it would hit the primary on its way down. We put in a nervous call to the Subaru members of the day crew, a group of engineers who worked on maintaining the 13 telescopes on the mountain during the daylight hours when the observers were asleep. The Japanese crew member we reached cheerfully informed us that he had, in fact, seen this happen earlier in the day, that the mechanized supports were probably fine, and it was probably just a false alarm, and that turning the power off and then on again would probably fix the problem. It seemed impolite to point out that we were talking about a multi-million-dollar telescope and not a modem. I didn't know what 400 pounds of glass hitting the concrete floor above my head would sound like, but I knew I didn't want to find out. I was also quite sure I didn't want to be forever known as the grad student who killed Subaru. I'd heard too many I broke the telescope stories over the years to ignore the fact that this was a very real possibility. One of my collaborators had destroyed an outlandishly expensive digital camera on a telescope by innocently touching 2 of the wrong wires together. The story had gotten back to his boss before he did. Another astronomer, this one a veteran observer, had slammed the business end of a telescope into a movable platform inside the dome that she had forgotten to retract part way through a sleep-deprived night. Sometimes these sorts of failures weren't even anyone's fault. A gargantuan 300-foot-wide radio telescope in Green Bank, West Virginia, had just up and collapsed one evening, crumpling like a stepped-on soda can partway through an observation. I couldn't remember exactly what had caused the infamous Green Bank failure, but I was convinced the words mechanized support had been involved. The cautious thing for me to do would be to call it a night, drive back down to the observatory's sleeping quarters, and have the day crew carefully check things over the next morning. On the other hand, this was my only night on the telescope. Tomorrow it wouldn't matter whether I'd experienced a mechanical failure, a false alarm, or even just some poorly timed clouds. Telescope time is strictly scheduled months in advance, and another astronomer would be arriving with a completely different science program. All that would matter was that my night had come and gone without completing my observations. I would have to submit a whole new proposal, hope for another hard-to-get yes from the telescope committee, wait an entire year, a full trip of the Earth around the Sun, until the galaxies were back up in the night sky to try again, and hope that night wouldn't have any clouds or telescope problems. I desperately needed these galaxies. Several billion years ago, each of them had hosted a strange phenomenon known as a gamma-ray burst. Astronomers' best guess was that these bursts were coming from massive, rapidly spinning, dying stars whose cores were collapsing into black holes and cannibalizing the stars from the inside out, igniting violent jets of light that came streaking through the cosmos to arrive at Earth as flashes of gamma rays lasting mere seconds. Stars died all the time, of course, but only a handful of them were flashing us like this, and nobody could explain why. I had built my entire PhD thesis on the idea that studying the chemical makeup of these stars' home galaxies, the same gas and dust they had been born from, was the key to understanding why they exploded the way they did. Subaru was one of the only telescopes in the world capable of such observations, and the day crew had said it was probably giving me a false alarm. If I called off the night, I'd be giving up what could well be my only opportunity to ever study these galaxies, losing a linchpin of my thesis research in the process. Of course, having the largest piece of glass in the world sitting in pieces on the dome floor wouldn't help matters either. I looked at the operator, and she looked back at me. I was the astronomer, so with all of my 24-year-old, third-year grad student still had to pay the young driver fee to rent a car wisdom, this was my call. I looked at the printout of my meticulously crafted observing plan for the night, which was falling further and further behind with every minute that Subaru sat idle. I looked at the fuzzy image of the night sky on my computer screen, coming from the small guider camera that was always on, and showing us where the telescope was pointed to help observers like me find their way through a bottomless sea of stars. I turned the power off and back on again. The simple act of stargazing is an experience shared by almost every human on the planet. Whether we're peering through the stifling light pollution of a bustling city, struck motionless by the riot of stars arcing over our heads in a remote corner of the globe, or simply standing still and feeling the enormity of space waiting just outside our planet's atmosphere, the beauty and mystery of the night sky has always entranced us. You'd also be hard-pressed to find someone who hasn't admired the dramatic astronomical photographs produced by the world's best telescopes, the sweeping vistas of stars, galaxy pinwheels, and rainbow-hued gas clouds that supposedly hold the secrets of the cosmos. What's less well known is the story behind where these photos come from, how and why we're taking them, and who exactly is extracting those secrets of the universe. Astronomer sounds like a romantic and dewy-eyed sort of job, and its practitioners are a unicornesque rarity. Of the 7.5 billion people on our planet, Fewer than 50,000 are professional astronomers. Most people have never even met a professional astronomer, let alone contemplated the details of such a strange career. When thinking about what an astronomer does, on the rare occasion that it's thought of at all, people tend to imagine their own experiences with stargazing taken to an obsessive level. A nocturnal geek peering through a really big telescope in a really dark place, maybe donning a white lab coat and confidently spouting off the names and locations of things in the sky as they patiently sit in the cold and wait for their next discovery. The handful of astronomers in movies also become a go-to reference. Jodie Foster hunkering down with headphones to listen for aliens in contact, or Elijah Wood peering through a suspiciously powerful backyard telescope to discover a planet-destroying asteroid in deep impact. In almost every case, the observing is merely the prelude to the real drama. The sky is always clear, the telescope is always working, and after a minute or so of wide-eyed awe, the movie astronomer dashes off to save the world with a few snippets of perfect data in hand. This was certainly the mental image of astronomy that I had in mind when I claimed it as my future career. I'd come to astronomy in the same way as countless other amateur and professional space enthusiasts, through a childhood of backyard stargazing in a New England factory town, Carl Sagan's writing on my parents' bookshelf, and those jaw-dropping photographs of nebulae and star fields that seemed to always show up as the backdrops of TV specials and science magazine covers. Even when I arrived at MIT as a freshman and blithely declared myself a physics major in my first step toward an astronomy career, I had only a vague sense of what I'd be doing all day in my chosen profession. I was becoming an astronomer because I wanted to explore the universe and learn the stories of the night sky. Beyond those broad strokes, I wasn't particularly fussed with what the exact job description of astrophysicist entailed. My daydreams were about contacting aliens, unraveling the mysteries of black holes, and discovering a new type of star. So far, only one of these has come true. I did not daydream about being the final decision point for keeping one of the world's largest telescopes intact. I never imagined that one day I'd be shimmying up the support struts of a different telescope to duct tape a piece of foam across its mirror in the name of science, researching whether my employer carried experimental aircraft insurance, or willing myself to somehow fall asleep next to a tarantula the size of my head. I didn't know that there were astronomers who traveled to the stratosphere and the South Pole for their work. Astronomers who had braved polar bears, faced down gunmen, and even died in pursuit of a few precious bits of light. I also had no idea that the field I was entering was changing as rapidly as the rest of the world. The astronomers I read about and imagined, swathed in fleece, perched behind an impossibly large telescope on a cold mountain top, and squinting into an eyepiece while the stars wheeled above them, were already an endangered and evolving species. In joining their ranks, I would fall even deeper in love with the beauty of space. But to my surprise, I would also wind up exploring my own planet and learning the stories of an incredible, rare, and rapidly changing, even vanishing field. Chapter 1. First Light. Tucson, Arizona, May 2004. I got my first glimpse of a telescope, a real, large, world-class observatory telescope, on the road heading west from Tucson. I had just finished my sophomore year at MIT, flying to Arizona straight from my final exams in quantum physics and thermodynamics, and was picked up at the Tucson airport by Phil Massey, an astronomer with gray, mad scientist curls, black-rimmed glasses, and a wide grin. My research advisor for the next 10 weeks, he was driving me to Kitt Peak National Observatory, deep in the Sonoran Desert, where we'd be spending 5 nights observing at one of the telescopes as a kickoff to my summer project. It would be my very first visit to a professional observatory. I had learned from our email exchanges that I would be studying red supergiants. Red supergiants are massive stars with at least 8 times as much mass as our own Sun. Because of their large masses, they've sped through their stellar lives at breakneck speed, taking a mere 10 million years to transform from their newborn state, brilliant blue-hot stars freshly formed out of gas and dust, to their current state, blazing deep red like a dying ember, and swelling up to many times their original size in a last-ditch effort to stay stable and alive. Death for these stars most likely means a violent interior collapse, followed by a rebound explosion known as a supernova, one of the most luminous and energetic phenomena in the universe, and the process by which black holes are sometimes formed. Phil and I had met just once before, briefly, the previous January, and he'd chosen me as his summer student based on a presentation he'd seen me give on my first foray into astronomy research. When we'd first started discussing plans for the summer, Phil had offered me a choice of 2 projects, literally red or blue, the red dying stars or the blue newborn ones. I didn't know a great deal about either, but I thought black holes were fascinating, and since the dying stars seemed fractionally closer to that point, I opted for red. At Kitt Peak, Phil and I would be observing about 100 red supergiants in our own galaxy, the Milky Way. I'd then spend the rest of the summer working with the resulting data, trying to measure the stars' temperatures and contribute a tiny piece to the ongoing astronomy-wide puzzle of exactly how these stars evolved and died. Phil and I chatted and got to know each other on the drive, but I was also gawking out the window at the southern Arizona desert. The baking summer heat and sunlight were stunning, a world away from the muggy green spring I had left behind in Massachusetts, and I took in the orange-brown dirt and stretches of saguaro cactus and beaming blue sky. Phil pointed out the tiny white silhouette and pair of contrails from a high-altitude jet and mentioned that experienced astronomers can gauge the quality of the sky they'll be observing that night based on how long the contrails are. If they're long and fluffy, there's a lot of moisture in the atmosphere to stir up and interfere with the starlight, while if they're short, just a little tuft trailing behind the plane, we would be in for a crisp and clear night. The jet we were watching had a short tail. Phil knew the drive to the observatory by heart and told me where to look at the exact moment when Kitt Peak's 4-meter telescope first popped into view. The white dome, 18 stories tall, glinted in the pounding desert sun. The telescope inside has made groundbreaking observations of everything from nearby stars to impossibly distant galaxies in the decades since it achieved first light, the moment when the completed telescope took its first look at the night sky in 1973. The vast majority of modern-day telescopes use mirrors to collect light from the stars, and the most fundamental property of these telescopes is the mirror's size. A larger mirror means that when we point the telescope at an object, a bigger area is available to collect light from the object. It's the same principle behind why your pupils dilate in a dark room. The distance from one side of a mirror to the other, its diameter, also dictates how sharp of an image the telescope can produce, like using a telephoto lens to get a clear photo of something small and far away. For well over a century, major strides in astronomy have revolved around the progression toward bigger and bigger mirrors, with their diameters dictating a telescope's fundamental ability to see farther into space. As a result, mirror size has become the defining characteristic of a telescope, to the point where it's sometimes entwined in the telescope's name, or even defines the name entirely. At Kitt Peak, the flagship telescope is widely referred to as the 4-meter. Eventually, we peeled off Route 86, already an incredibly barren and empty stretch of highway, and started winding our way up a meandering mountain road. At first, there was very little sign that we were going anywhere but deeper into the desert. Long stretches of pavement, some switchbacks, and minimal signs of life at all beyond the cacti. The only clue that we were heading to an observatory was the occasional curve of a white dome peeking out from between the hills. Later on, we started getting a few hints that we were not on just any mountain. As we neared the summit, signs started appearing, imploring nighttime drivers not to use high beams, and eventually not to use any headlights at all in an effort to preserve the mountain's darkness. Today's best observatories are built in the high, dry, remote places of the world. High altitudes give us a slightly thinner atmosphere and less turbulence in the air between the summit and the stars. Deserts mean air devoid of water vapor and moisture, good for weather and for image quality. The reasoning behind the remote locales is a bit more obvious. The farther we are from the rest of the world, the darker the skies. Although even the darkest parts of the planet are fighting a constant battle against encroaching light pollution. Kitt Peak lies near the southern border of the United States, less than 30 miles from the Mexican border. The mountain itself is all brown rock and stubby trees, indistinguishable from the desert around it, but for two things: the white domes hunkered like sleeping giants across the long summit ridge, and the invisible but very real perfection of the air passing over the summit. The land around the observatory largely belongs to the Tohono O'odham Nation. A prominent rock formation in the distance, shaped surprisingly like a telescope dome, is known by them as Babakivari and is, in their cosmology, the center of the universe. As our car climbed, I found myself wondering, what's a professional observatory going to be like? I had a mental picture of a big behemoth of a telescope like the one we'd spotted from the road, perched white and alone on some stark rock outcropping of a mountain ridge, but that was about it. I hadn't much thought about details like where we'd sleep. During the day? Would we sleep? What we'd eat? Should I have brought some snacks? Or any of the other logistics? I figured it would all sort itself out, and focused instead on drinking in our surroundings as we neared the summit. Taunton, Massachusetts, 1986. Not quite knowing what was coming was not a new sensation. I'd long since come to terms with the idea of optimistically plowing forward with "I want to be an astronomer" as my guiding plan. I'd been enraptured by space for as long as I could remember, but the original spark could be traced back to early 1986, when Halley's Comet made its most recent close flyby of the Earth. My parents and older brother and I lived in a suburb of Taunton, Massachusetts. A blue-collar southern New England city with industrial roots, it nevertheless gave way to forested streets and ponds and cranberry bogs once you made it a few highway exits out of town. Dark enough for stargazing. Neither of my parents were scientists by training. Before I was born, they'd both earned teaching degrees with a focus in special education. My mom worked as a speech therapist, but eventually went back to school for a graduate degree in library science and moved up through the library positions of the Taunton school system. My dad had studied teaching, but worked as an independent truck driver for years while becoming a self-taught computer expert. And by the time I was born, he was working at an insurance company as an IT specialist. Still, both of them were scientists by nature, fundamentally curious about the world around them, and constantly eager to learn as much as they could about whatever corner of it might catch their attention. My dad had taken an astronomy class as an elective in college at Northeastern, which made enough of an impression for him to take it up as an interest and pass the enthusiasm along to my mom. In keeping with their lifelong habits, once my parents got into something, they were into it full bore. When that something was astronomy, my dad scraped up funds to buy a backyard Celestron C8, a squat orange cylinder with an 8-inch mirror, and built his own table to mount it on, along with some added shelving to store eyepieces, equipment, and a copy of Norton's Star Atlas. The flames were further fanned by Carl Sagan's Cosmos television series premiering in 1980, which prompted my librarian mom to stock up on his books. By the time I was born in 1984, astronomy was a background buzz in our house in the same vein as gardening, woodworking, birds, and classical music. My parents were determined to give my brother and me a rich and varied set of potential interests to explore. Still, the real catalyst sparking my interest in astronomy was my brother Ben, almost 10 years my senior. I'm fairly convinced that when two siblings are this far apart in age, hero worship is just part of the package. Growing up, Ben was always the first and foremost arbiter of all things cool in my eyes, and he was endlessly patient with me, rather than annoyed by a tiny tag-along. Ben played the violin, and therefore I asked to play the violin. Ben did science fair projects, so I started fashioning nonsensical experiments out of whatever toys or household items I could get my hands on. I even wanted braces because Ben had them, an opinion that was reversed rapidly once I was the one in the orthodontist's chair. In February 1986, I was 18 months old, and Ben was 11, studying Halley's Comet for a school project. These sorts of projects always became full family endeavors, so all four of us tromped out into the backyard one cold winter night, armed with our 8-inch telescope and its homemade table, to get a glimpse of this once-in-a-lifetime comet flyby. It's next due back in 2061. According to my parents, I was brought out to get a brief look, with the worry that I might be a typical fussy toddler, scared of the dark and eager to get back inside. Instead, I was entranced, gazing up at the sky, staring through the telescope. In retrospect, I'm amazed that a not yet 2-year-old could look through an eyepiece, but they swear I managed it, and refusing to go back inside as long as Ben was still observing. The love of astronomy stuck in a way that my love of braces didn't. I was an early and voracious reader, and a few years after Halley's Comet, I was learning about star clusters and black holes and the speed of light thanks to Jeffrey T. Williams's Planetron books, which chronicle the adventures of a little boy with a toy that transforms into a magical spaceship and sweeps him off to explore the heavens. I have a strong memory of being 5, reading about how fast the speed of light was, and repeatedly flicking the light switch on and off in my room to convince myself that, once I flipped it on, the light arrived pretty much instantly. That seemed pretty fast to me. Later, I inhaled every astronomy book I could get my hands on, watched Mr. Wizard and Bill Nye on TV, and went to every movie about scientists and space that came along. I remember particularly enjoying the movie Twister because it gave me an encouraging look at what scientists themselves might actually be like. The fictional tornado researchers on screen were doing cool and exciting research and having fun along the way. And the main character was a woman who rolled around in the mud and was obsessed with science, but still managed to end the movie with a great kiss. A combination I'd already been warned might not be tenable in the long run, thanks to plenty of other movies featuring women who had to choose between careers and men. My parents did what they could to encourage my interest in space, but opportunities to explore a career in astronomy aren't exactly found on every street corner. None of us even knew a professional scientist, let alone an astronomer. And while my entire extended family was filled with kind and bright and enthusiastic people, nobody had a PhD or knew much about what this sort of job entailed. All 4 of my grandparents had left school at young ages, despite being uniformly strong and passionate students, to work in local factories and contribute income to their families. My maternal grandmother in particular had been devastated by this, and wept the day she left school. She later returned to complete a high school degree alongside my grandfather, Pepe, and went on to get a practical nursing degree while raising 5 kids, with Pepe working at the big silver factory.
Sample complete. Ready to continue?